Hello everyone. Our objective in this tutorial is to learn how to be effective user of both Closure and the decorators in Python. My name is Avkash, and in this tutorial we are going to learn 5 more very important concepts related with Python programming. This tutorial is divided into 5 different topics. First 2 topics are the foundation for us so that we can learn both decorators and the closures effectively. One thing you must understand and accept that everything in Python is object. So even if your class is also an object. So first 2 topics are mostly focused on functions, and reason we are covering functions in first 2 topics so that you can learn both closures and the decorators effectively and correctly. So very first topic is all about assigning functions to your object and also passing functions correctly. In the second topic, you are going to learn how you could nest various functions within a main function and how to nest them correctly. The third topic is all about mastering Closure. We are going to use few examples in the topic so that you can learn effective use of closures. Number 4 topic is all about decorators. You are going to learn few different ways how you could define the decorators, how you could use them, and how you can chain the decorators and even the pass parameters. Last topic is all about data binding with closures. In this topic, you will learn how you could pass the data in a closure function. Not only that, I will also show you that where the data is hidden in the closure function also. Closures are quite similar to classes, so you will also learn that when and where to use closures and where to use class. Which one is better depending on which situation. So I believe that these 5 topics related with both closure and decorators are going to help you a lot. By using both decorators and closures effectively in your Python code, you can not only impress your contemporaries, developers, and you can also prove others that you can write in the effective Python code. So let's get ourselves started. So let's get started with the very first topic in our tutorial, and that is the functions in Python. You must have to accept the fact with Python is that everything in Python is object. Whether you call it class, you call it function, even the functions are the object. So let me define a function. This is our first function, and it passes a parameter message, and whatever the parameter is, that is being printed here. And if I will call it, that is going to render. It's a very simple thing, almost everybody knows. Now we can do a object assignment. So we can say second function is equal to first function. Now if we say, let's call the second function is part of first function, as it see, because we are not calling the function correctly with the parentheses, but if you would want to call it here, hello again, is referencing to very first function. What you are seeing here is the function is assigned to another function, or the function is referencing to another function. So we have seen a function is being referenced by another function in this example. Now let's take the another example where how the functions can be called. So I will try to derive a couple of these functions. So there is a add, there is a parameter called the number, and here is going to return the number plus 1. Then I will call it subtract, here the number minus 1. Then I will call it cube, where we will return times number times number is square and is 2 times. So let's define the function. Define, and this function is going to be a multi-function caller. So we will call it multi-math function. One parameter will be the function, another parameter will be the number, and this function is going to return any of the function which we are calling and the number which we are passing to this function. So that is our multi-math function. Now if you would want to call the add, and I would say we are giving the number 10, and it's going to call this add and it's going to return the result of that. If you are taking this multi-math and you are saying I would like to get the cube of 10, you will get this. If I try to call this and I say, hey, can I get the square of 10? So you got the idea. You got the idea that here we are calling the function within this function, and then we are getting the result out of that. So this concept, what we learned, can be considered as the function is calling another function as parameter, because here we have called another function as the parameter. Not only that, you can actually pass 2 more parameters. So if we call it 2 parameter related, so you could actually say here func1, func2, for example, if that is what you want to do, and you can say multi-math double, and this is going to return the result of both of these functions. So you could see here that result will be, so that is going to pass func1, func2, and then if I call here and I say, oh, I want addition and I also want the subtraction of 10, it is going to give you the subtraction of 10. 10 was used, 10 was used. So after the 2 different ways you have seen the function assignment, a function is referencing to another function and function is calling another function as parameter, the next concept comes in our mind is to handle the nested functions. So let's take a look now. So it will be the main caller function. That is our very first function. So that is our main caller function, and that is function is going to have another function which is, I call it inside return function. They both are functions, and this function actually print, and this function we have to make sure that the main function is returning the inside function. That is our main caller function. If you take this main caller function and you just try to say what is main caller function, so you will say that main caller function is actually the main caller function. If you take this function and you try to say, okay, I want to call this thing, you will get to know that this main caller function is going to call the inside caller function. So that's the definition here. And then here, how's the implementation of this function is that you got. Now you can assign an object for this function. So I will call it new function object. This will be the main caller function. So let's have the main caller function. So what is this new function object? So new function object is exactly the same. However, if you say I want to get the new caller function working, this function is actually calling the nested function. So you have learned how we could create the nested functions in Python. Next, we are going to go a little more deeper, and we are going to look into how the parameters are worked inside here. So I will take the same function here. I will create another cell. Let's use this one. So this is the main. So I will call it main caller function with params here. So now we have parameters with this one, and then inside return function is part of this, and what it's going to do is that this function is going to have a parameter. So I will say the parameter is the username, and this username parameter will be used here. I can say dot format. Let's use this way. Now we can do again same exercise. If you look into this is a main function. If you try to define as a caller, here you could see that this inside return function has ability to get the parameter. Now we create the new function object. So I will call it second function object. This function object is actually assigning. If you look into what the second function object is, that second function object is same as this. Now if we try to pass the username here, that is going to be, so username is Avkash here, and if you will see that Avkash is used, so you haven't passed the main color function parameter. The parameter was actually passed to a local variable. However, the second function object has been body for your parameter to pass. So first you have seen the passing parameters to the nested function, and second you have seen that we haven't actually passed the parameter to the main function, but still we were able to pass our parameter through the local variables within the function, and that happens to be our next topic, and that is what we are going to learn in our next Jupyter notebook. So let's understand Closure in Python with this particular example first. So let me create a function here, and we are creating the outer main function. This function has a parameter, so we call it passing parameter, just to make sure what it is. Then we are going to create the internal functions, internal nested function we have created, and this function is going to print the passing parameter. Now we are going to call this function. So we are going to call this function, and that's what our function is being called here. So let's try to look what we are doing here. So first here we have outer or the enclosure or the master function. This is our nested function, and one more thing we need to understand, that this function passing parameter, and which is non-local parameter. So this passing parameter is not passed here. It passed to this function. However, this function is going to access the parameter, and then whenever this method will be called, that whatever the action of this function is, that will run here. And here we are calling the internal function. So the way it's designed in this whole system is that whenever somebody calls this function is basically definition and run. So you will call it, means you can say that whenever this function will be called, this function is actually going to run. Hopefully that clarifies you that this function will be called, this function will be run. So let's take a look into this, and I think there is a typo. Now it's okay. So this parameter, everything is correct. This is correct. So everything is okay. Now let's take a look. This function, you already know this is a function and it has a parameter. So we can actually take this and then we can look into what this parameter look like. As you see, that is need a parameter in order to make it run. So we will call it my parameter. This function passing parameter was passed. We haven't passed this to there, but this method has ability to access this local variable because this passing parameter is local to outer main function. If you try to define this thing, and you can say new object equals to this, and whether you call new object, if you see here, the new object is not returning anything. So whether you call this or whether you call this, they both are working same way, and if you try to say what is the new object, it does nothing. So you have seen that we have defined this function and then we were able to successfully pass the parameter. Now I will take the same example, and remember one thing we are doing is that we are not returning, but I will return this thing next. So same method, I will call it outer main function, okay, and I will just call it with return, and this function is what is going to return this function, and then it is not calling it. It means this is the internal function, same everything, calling, and here we will say returning the internal function. That's what the definition we have changed a little here. So that's one big difference. Now if you take this function and if you will call it, you will see that this function is just basic function and you have to pass the parameter. If you take this, you do this, it will expect a parameter to be passed. I will call it new param is the passing parameter. And if you see here, this is a function which has an internal function is going to call, and it expects us to take this function and try to assign an object so that it can work because of this return. So it can work because we have to do a new assignment. So I will say new object equals to whole of this. So this is what our function, and we can assign it. And now if you try to say what is new object, so new object is type of exactly the same. However, in order to make this new object work, you have to call it. So now there is a very big difference you need to understand. This new object does not know anything about new param. The new param was assigned when new object was assignment was happened. The object was assigned for this function type, and then whenever you are going to call the new object, the new param or the parameter which was passed is available. So we have seen two separate ways how we are creating the internal function and how we are passing the parameters. So we need to learn what had happened here. So let's try to understand. So let's take a look what had happened above. So the outer main function was this. It was called with the string new param. The function this is bound to the new object. So this is our new object. It was bound to that. When we called new object, we did not pass any parameter. However, the message new param was still remembered inside this function and returned when we called it. So this is what happens in the closure. So this is the definition of our closure. So closure is a process in which the data, whatever data is really would we want, in our example, new param is the data. So the data get attached to the code whenever it is called. And that's where whenever it is called, the data, whatever we have defined in the function, that get attached to. Next, we can see when we could use closure. So you can use closure when the following conditions can be met. First, you have a function inside the function. It means you have the nested function. The nested or the internal function must refer to a value defined in the outer or the parent or the enclosing function. So this function must be able to access a parameter to that. So that's the requirement for the closure, and the finally or the outer or the parent or the enclosing function must return the nested and the internal function. So it means that it has to return this. So if you have these three things, first nested condition, second there is a parameter, third there is a return. So 1, 2, 3. If you meet these three conditions, you could actually use the closure, because that is what the closure requirements are. It means that once you understood, you have a need where you need to hold, you need to first define a parameter or pass a data to a function, but you need to later recall that whenever there is a need, you could use the closure to achieve your objective. So after we have covered closures in Python, now it's a very good time that we could start learning how and why and when to use decorators in Python. I will take an example and then I will define you it extensively. So let's define a function. So I will call it, there is an outer function. So we have an outer function, and this function is actually passing a function. Now we are going little more deeper into the complexity or the writing the complex code in Python, and we are defining the inner function. So this is the inner function, and this function is defined as very simple. I think it's a very clear, and then this function will be called here. So this function is going to be called inside this inner function. So we are making sure when it is really being called, and this inner function is going to be returned now. So this inner function is being returned. So this is our outer function. Okay, now we are going to define another function. So I will just call it define just a function. And this function is going to print, there you go. So we have two functions. Outer function which has inner function, and this function has a function as the parameter, and this function returns the inner function, and this is just a function. So now if we try to call just a function, we already know this is type. We have to make sure that this function we have to call like this way. So I will just make sure that I'm calling from here, and there is no need to pass the parameter. It can take a parameter in case if you would want, and then it's just a function. So far everything is very clear to you. Now if we take the outer function and we say what is outer function, this is outer function which passes the parameter as a function. So now we need to take the outer function, and if we try to do this way, it's going to give error because it's expecting a function argument func, and that func in our scenario is a function. So we will say the outer function is actually taking the inner, this definition of this just a function. So outer function, now we have passed the just a function, and as you could see here that this is inner function, and remember it's a return here. We just learned in the just previous Jupyter notebook, or the third topic in our lecture, is that when you have return, you really have to assign an object for that. So we need to take this thing, we need to assign this thing to an object. So I can call it color object here. So color object has assignment of this outer function, which is actually taking this just a function as a function. And remember, the function is going to run after the inner function. So now if we take the color object and say what it is exactly the outer function, just a function, and because its a assignment is a function, so we have to look into this as a parameter. It means it's going to return something. And if you run this thing, you could see that first line was the inner function, and then second it ran the function what is being passed here. Oh, let me just, there is a typo, it doesn't look good. We have to do the assignment was here, color, and then that should fix this error. Okay, it was just typo. So what has just happened here, what we have just seen, we seen the decoration, and let's go step by step. So the function just a function is got decorated by the outer function. So what is a just a function? So remember, this is a just a function, and we have passed this just a function. So this just a function has been decorated by the outer function. So this was the body or your gift or the package, and the outer function was the decorator function. So whenever this object, color object, so whenever this color object was called, it has both outer function and it has the inner function of the just a function. And then whenever this color object was called, the outer function's inner function was called first, and then this function was called. It means the outer function, inner function has all the packaging, all the decoration, whatever was needed in order to decorate this second function or the function which was passed. So we could say that whatever the value of this function was, it is decorated by the outer function. So hopefully now you get an idea that the decoration means that we already had this function. We wanted to enhance this function through some other way. So we didn't wanted to touch this function, and using this outer function, we have enhanced the capability of this function, and that is what a decorator does. So what decorator does, we have already seen, and now we can understand that why we are using the decorators. So we are using the decorator so that we can extend the behavior of a function without modifying the function code. So we wanted to enhance the just a function capabilities. However, we didn't want it to make a code change, so we use this outer function, and then we call just a function in this way. So whenever we are going to call this color object, that is what is going to take care of whatever we would want to enhance the value in a just a function. Second, the decorators, they are applied to a function by prepending the @ symbol. So now it comes that, okay, what that mean, how to define a decorator, properly, and that is what in our next step. So I will take the very first function which we have just defined earlier, and I will call it outer function new. So it's just a new definition, but everything is same. And now I will be using the just a function, and this just a function is also the new function. However, this outer function, I will be saying that outer is the decorator for this function, so I can use the @ sign here. So this function is the decorator for this function. It means whenever this function will be called, this function will execute first, and it's going to take care of the decoration of this function. So now we can just define a new color object, and this new color object is actually calling this outer function, which has the newer function, the new color object we have called, which is type of this. Now we can make sure as soon as you call this function, you see that what had happened here. So if we assign this new color object the older way we have done, we have seen something which is not correct. So this behavior is not correct. So I would say this assignment, so this assignment is incorrect. So this assignment is incorrect. So what is the correct assignment? So the correct assignment will be, I could say, is a new color object for decorator. And the way you are going to assign this object is that you just really don't need to worry about it, because it's not really needed, because it's already been packed together with this statement. So we just really need to assign this, the target method. We are not really trying to change anything here. So just a function, and now whenever you are going to call, it's already returned our expected result. So if you would want to assign this way, the better option is that you take this thing and you can say it's actually the, and now whenever you are going to call, it is same as your function, so you could call that way, and there you go. So this is the better way to assign your decorator. So this is the better way to do. So we have function with decorator assignment. Now our next step will be that what if we could actually decorate a function through the various decorators, means can we chain the decorators? So our next step is to look how we could chain the decorators. So I'm defining a new function called, so this is our master decorator function, and it takes a function as the parameter, and I'm defining the inner function inside master decorator function, and thus, and after that we are calling the function which is passed, and we are returning the inner function. That is our master decorator. Now if we want to call the commander, so we have master and then we have commander. Now we can create a new function which called the definition just a rookie. So this is our rookie function. Now we are saying that okay, let's decorate it with master, and then let's decorate it with commander. So master commander decoration. And now if you are going to call just a rookie, you see that decoration has already been done for you. So this way you could decorate. If you want to change the order, and that's all up to you. So these decorators are going to be processed depending on the order they are set to their function. Now, what if we have decorators which needs parameters? So how we could defining decorators with parameters? So I will be writing a new example. So let's create a new example. So I have these zip codes. So let me make this way. So we have zip codes, and these zip codes are, so we have these zip codes. Now I'm creating a function. The parameter is zip2find, and here we are trying to do, and this is going to be zip codes. So if the zip code dot index, if it could find the zip2find, it will return the index. If not, it's going to accept. If there is a value error, it will return -1. So that's pretty much our method zip code to find. So if we want to check this method, we can say, hey, can we find 94401? It found at a 0 location, but if we find 409, it returned -1. So we got how everything works. If you think that this is the function you have and you would want to improve this function, if the value passed are the numbers, they are 5-digit numbers, or they must be within some criteria, then you can actually create a decorator function. So let's create a decorator function and we call it zip code validator function. And this function is actually takes a function creating the inner function and is going to take this zip to find. And remember, this is just a parameter, and we are saying, so we are searching format and it is going to take the zip to find. And for example, if there are two conditions, so if we have these two conditions that the zip code must be an integer and it must be a 5-digit number, so we could create the condition. So we could say if the integer, so we can check this zip to code, it is integer, and if it is not an integer, so one condition. Or we could also say that if the zip code is less than 10,000 or the same zip code is higher than 99,000. It means if any of these conditions are going to met, then we can say, can you print it? And it will print match any of it, else it is going to call this function and it will take the parameter, and this is going to return it. So that's we have done. And finally we need to return the inner, so we have returned the inner function here. So this is how we define our validator. Now I will take this function, I will just call it that this is actually going to use the decorator. This is with the decorator. Now let's add the decorator to it. Here is our @decorator, that's all. Now if we take this method and say, oh, what is 94401, which is there, searching, okay, and if we say 94901, it's not in list, but it's a valid number. So if we try to give a number which is not, so for example, if I say what was 92, and it will say it is not a valid number. So you have seen how we could define a decorator to enhance the capabilities of a function without modifying it. So if we would want to summarize what we have learned about the decorators, we could say that the decorators are the glorified function extenders, and they can enhance the value or enhance the capability of any function, any given function, without touching the code of the function. So you have learned various ways to implement the decorators wherever it's applicable. So now take a look into our last and the fifth topic in this tutorial. And our last topic is data binding with closures. So in this example, we are going to combine the most of the concept we have learned, like closures, like decorators, everything, and then see how the data binding can be done through closures. So let's define a function. So I'm defining a function is called the multiplier. So create, this is our multiplier function, and number to multiply with, that's a parameter, and I'm going to create the internal multiplier, and here we are passing the number. And remember, we have already learned that this is the variable which is going to be passed. This is what is the variable which is going to be accessed locally, and here we are say returning the pass the number. So this number we have is going to be multiplied with the number we want to multiply with, and we could say let's return our internal method. So we have seen this several times again, so it's not something new to us. If we try to say what it is type of that. If you will try to use this and say, hey, I would like to use the object as a function, it will say, oh, I really need to provide a variable. So I'll say I would like to pass 10, and now you have passed the 10. Now it knows that, okay, I understand this is how you are going to call, but in order to run this internal multiplier, we have to make sure we do proper assignment. Correct? Assignment is very important for us. So I will create a multiplier. So what I want to do is that I would say multiplier of 3. I'm create the multiplier of 3, and I'm going to create the multiplier. And every time this multiplier of 3 will be used, it's going to multiply by 3. So create multiplier, this is the number to multiply with. So multiplier of 3 is going to be used as a multiplier of 3. That's what it is. If we try to say what it is, it's a function and pass the number. So I will just use this and I will try to write here. So this is how we have defined the multiplier of 3. Now we can create another multiplier, which is the multiplier of 4, and it will try to multiply 4. I will create one more multiplier which take any number and then it multiply by 100. So this is a multiplier of 100. So you could actually define variety of way. Now you have defined these multipliers, now you would want to use them. So I would say that in order to use them, you can say, oh, I want to have multiplier of 10. And what if I would say I would try to use a 10. So I'm passing the number 10 to multiplier of 10. So multiplier of 10, which is the object I'm passing. So that's pass the number is 10 now. And the 10 will be multiplied by the 100, and then you are going to get result. I can use any of this. I can say multiplier of 3 is going to be 30. Multiplier of 4 is going to be 40. If you would want to change these multiplier, you can actually say that the multiplier of 3, and it is the multiplier of 100 to the value 5. So what is going to happen? 100 times 5, 500 times 3, 1500 times 4, 6000. 6000. You can change these objects. So we have created this multiplier, but we could pass the data differently in a way that the same object can be referenced, and it actually has so many objects its own the way you would want to define them. I just wanted to let you know that the example I have taken is, I found a similar examples at this location. So please feel free to visit this article and you can learn more about it. I just wanted to make sure that I gave the credit to the person because I liked their example, and this example was really very easy for me to explain you. So one thing we have learned is that if you see that we have created a multiplier and we don't really need to pass the global values. So we can now learn that where the closures could be very useful. So closures are very effective for two reasons. Main, that no need to use the global values, because here we are not using the global values. This example could be very simple to understand. And second, you are hiding the complexity of your processing plus data within the nested function. So this function is hiding everything inside. So create multiplier was used, and if you look into that, the internal multiplier, this function did all the work, but it was always hidden inside the create multiplier. So for these two reasons, you can assume that these closures are very effective to use. So one thing quite confusing for some of the folks, that when you are calling this, so let's see. So I'm saying multiplier of 4 and I'm passing 5. It's going to return me 20. So this multiplier of 4, if I say what is multiplier of 4, it's a type of internal multiplier, and it's take the pass the number, which we already know what the number is being passed. So how calling this multiplier of 4 with the number 5, the 4 is multiplied by 5. So where this number is hiding, and this number is hiding is actually inside the closure. So if there is a closure, you can say dot to underscores, and then you can say closure to underscore, and that is going to give you the closure. It means that actually there is a closure object. So the number 4 is actually stored somewhere. So if you would say where the storage happen, you take this object and you can say give me the very first object, and you say if you look into, definitely there is a one value stored here. Now you could use this and you can say I would like to get the value of cell. So cell contents, and that is where this value is stored. If you look into the multiplier of 100, and it will give you that this value has cell content has 100. So if you have made this more complex method, you have lots of data within your closure function, you can get a list of all the data where everything is being hidden in terms of your function. So we can summarize this information. So if you have a closure function, so this function must have a closure attribute. So you could say that this function must have a closure attribute. So it's a closure, and if you will call the closure with the cell contents, you will be able to get the value what is being hidden for you. So before you go, I just wanted to let you know that all these 5 Jupyter notebooks are available at these Python tutorials folder in this Python project repo. If you go to notebooks folder, these 5 Jupyter notebooks are related to our tutorial which we have covered today. I hope you have enjoyed the content we have covered in this tutorial. So that's all I had for you in this tutorial. I hope you have enjoyed the content in my video. If you have liked it, please do share it. Please subscribe my channel and also comment your feedback or any suggestions you have. I do appreciate your time and I'm looking forward to see you in my next video. Until then, please be good and do good. Thank you.